So we started out and we obviously wanted to be remote control. And we did that through a graphical PC interface to provide control to the user. And there's also a movable roof camera on there that we wanted to control. So the high level of the design is you have the graphical user interface over here, which will hook into a wireless transceiver. So you have your computer and your wireless here. That'll send signals over on this side to the remote system over there, which has another wireless transceiver, and that contains, it's difficult to see over there, the drive system, Canon system, and sensors. And also with the wireless, the remote system over there, that's run off a 9.5 volt battery pack. So we started out with the GUI design. We wanted to be easy for the user to see what the tank was doing. So easy to see its cannon position, the sensor values that it's reporting back as well. And then they could control it using keyboard keys. Easy to do, and a little quicker than clicking on things. We wrote it in Visual C#, and it got kind of cut off there, but you can see in the upper corner is the cannon position, horizontally and vertically, and then down at the bottom are some of our sensor controls. The wireless communication part, we decided on getting a Zigbee radio, which is a 2.4 gigahertz radio. Our reason for doing that was it got pretty good range and reception. I think we got up to 400 feet indoors, which is pretty good. And also it provides a transparent mode, what they call it, where we could provide basically serial RS-232 data to this little transceiver, and it'll send that over wirelessly, and on the other end we'll get serial data back out. So it acts as a transparent wire without a cable connecting it to it. We thought that was pretty neat. We wanted to give that a shot. And they also offered a 10% student discount, which that was nice. And Jared, now is going to start us off with the drive system.
Okay. The drive system is the system that simulates the driver, for example, controls the movement of the car forward and backward. It controls the steering, turning right and turning back, and making straight. So it has two parts, steering and driving parts. So this is a high-level lockdown level of this driving system. It starts from the actually from the user. The command comes to me. From the peak, there was going to steering motor and throttle to drive the motor. So there's also a feedback from the steering to accomplish or to execute the coming command properly. It should have knowledge of what's the position of the steering wheel, so that can perform the command properly. But for the driving case, it's two terminals, drive forward or drive backward. There are simply terminals across the motor, so we don't need for feedback. There's actually analog part between these things that changes the peak signal, which is the digital 5 volt signal into the 9.6 voltage. We just have a switch to turn which side of the motor on and off. The steering system, let's see, the steering system is a little bit big. So it has units involved with the peak, the DC motor is hybrid. The signals involved in the steering system are the motor terminals, just as I said, terminals and the feedback signals that are coming out with the peak. This particular was the edge bridge. It has actually, there are some transistors and resistors. This is a high level diagram of the edge bridge. And the C are connected together, and the E and the T are connected together. when the big signals and this part of this side of the motor gets 9 volt, and this side will connect to the ground and turns one way. The other case, when P and D are signal, as they switch that 9 volt towards 0 volt, so the terminal of the motor inverted, so it will rotate the other direction. So we control this use a switch to interpret the fixed control signal of the when 6 when it's fully charged, that was the button. So the driving, the unit involved in the driving same peak is there, this motor there, but the signals are feedback in the same kilometers. And it works the same way. There are 2 signals, so the big controls those signals through pitch to drive for our the operation of the steering, it's responding to these commands, turn left and turn right at the same time. They are coming from the user interpreting the beat and pass to the steering system. So when turn left is command from the user, the beam understands that and signals the appropriate terminals of using the feedback as well as the coming signal. It outputs one of the terminals of the motor to turn left, center, or accordingly. So same way, turn right, center responds to each of these coming commands. The driving system responds to these commands that are coming from the user again, and we will interpret it in the peak. And any of those, the hybrid terminals will be turned on so that the appropriate command will be executed on after driving on the car, on the motor of the driving or the driving motor. So when driving is it comes from the user to be interpreted in the same way in the peak. So the peak signals 5 volt voltage to one of those, the H bridge terminals, 0 volt to the other. So that H bridge also turns the switch of the 9.5 volt, 9.6 volt to drive the motor in the corresponding direction. Back up in the same way, stop, during the stop, most terminals will be off. Whenever the motor was running, whether it's back up or I was driving forward, when stop comes, it's obvious what terminals will be off. This is low-level activity diagram of the driving system. It's not visible. This check for new command. So our task, there are 2 tasks in our. So if there's no new command is requested, or so the scheduler doesn't have to go to smooth system. So we need to check that one, and when, as you see, these 2 streams, which is very short ones, are for driving, drive for backward and stop. They are short activities. So the steering takes a lot of the activities. All these are and these are activities during steering. So the steering looks like a little bit complicated compared to the driving.
So I don't know if you guys have seen this. This is our prop. You can see this is basically what we're implementing our design on. This is an HT part to get everything out. And so this scanning system is going to go just right on top. This isn't what we're actually using for it. It's just an extra about to play with. but I gotta ask, does anybody here like the CSE blimp that flies around the atrium? It's okay if you do. No. So we were inspired to make some sort of vehicle that can shoot the blimp down potentially. So we started prototyping, and it can't really shoot the blimp down, but I'd like to think someday it might. Okay, so if you're wondering what the cannon system is, it's basically just two things. It's just some servos and a cannon. We interface with it, but I mean, it's a pretty simple system looking at it from a high level. So you see here, there's some inputs that the user gives. It goes to the cannon control, which is going to be done through the PIC. It's going to tell the cannon